Hello everybody and welcome to this tutorial how to model a Japanese frying pan with Shapr3D. In this lecture I will show you how we only need to create very basic sketches to block out the main proportions and then add all the details just via direct modeling. Let's have a look at the final design. By the way, you can download the file for free, dissect and learn from it. Here what you see is just the geometry of the final design. We have the frying pan area and the handle. Let's take a look at the sketches. There you can see for the main cooking part, I only created a rectangle. And then via direct modeling, I created everything else. I'll go back to the sketches and here, this is just for the handle, just again a rectangle. And I use the Revolve command and then the extrude command and the join command to create all these details. This is basically what I mean with for this design, all we need are very basic sketches and then all the rest we just do via direct modeling. Before we continue, I wanted to point out also here, there are few circles. You might ask yourself, what are actually these circles for? Well, these circles are representations of the dimension for fingers. And this way, then I can block out where my fingers would be and then figure out the angle for the handle. Okay, with all that said, let's go to a new file. Here we are in a new scene. Before we continue, we want to make sure that units is set to millimeter and all our snapping targets are turned on. Very good. Then let's go to the top view. Finger and zoom out a little bit till we see 10 millimeters. And then somewhere we start sketching a rectangle. I have by choice the auto constraint turned off because I like adding all the constraints the way I want. So this is just only a personal preference. With a pencil, I will double tap one line that selects all lines, and then I will select horizontal vertical constraint. Very nice. This line here should be 140 millimeters, and this should be 160 millimeters. There is a midpoint on the rectangle, and that one I can just move right to the center of my world. There it is. Very good. Can drag those out. And that pretty much is all we need to create at the beginning for the frying pan. With the pencil, we will select the profile and then extrude this 35 millimeters up. Very nice. That is now a beautiful block. Now this beautiful block we want to turn into an even more amazing looking frying pan. The front face is slightly rotated by 15 degrees. So we select the face, go to move and rotate, move the widget down to this edge. So the rotation happens over the edge. If we do not do that, then the rotation would just take place at the center of the face. There. The back face is also a little bit rotated. And also the sides. I will go with 5 degrees for this video. I personally own this frying pan myself. It is actually really excellent to prepare normal or rolled omelets in it. And those slightly angle faces really help getting your spatula or cooking tool under your omelet, for example. So this is pretty much all we need. Let's select all those vertical edges, and we would like to rotate this by 15 millimeters. I tapped onto the arrow, then entered the value, or you can also slide it. And then pay attention to how this deforms and select the value you like. One additional rounding, now this time across the bottom edge. We would like to add a thickness to the walls, or actually create walls. And this is very easy. All we have to do is select the top face, select shell, and then we type in 3.25 millimeters. And that command basically cores out this aluminum block and then creates kind of like this design where we have exterior and the correct interior roundings. That's the reason why I made the block, rotated the edges, rounded the edges, and only then shelled it. It's very important. Good. The bottom has actually a thicker material thickness. That's for heat transfer, etc. important. We will do this a little bit simplified. We will select the bottom face, and then we will go to offset edge and move this in just a little bit. 3 millimeters is fine. Very good. And then this new sketch, which is also a face, kind of like on the geometry, because the geometry is visible, and we extrude this one -3 millimeters. -3 because we actually, here's positive Z and here's negative Z. Very good. To make this actually look better, we can give this a nice rounding. There we are. Cool. Okay, so we'll go to a back view or front view. There we can see, how the bottom part has a thicker material. Very nice. Okay, good. Top view. Now it's time to model the handle. That's actually also really, really easy. So I go to the front, and the handle, I just draw somewhere a line. There we are. Should be 130 degrees. And the distance handle to the frying pan is 40 millimeters. These two lines I would like to be 180 degree or tangent. I use a tangent because in this way I only have two icons. I could also use the angle constraint, but then I have a little bit more in my view, and this way this is cleaner. There's less actually in my way with the pencil. So how do I connect this perfectly to that point? How do we do this? Super easy. I need to find this edge, and I will do it this way. So here is a line, or I can also use this line. And then on the left side, go to more, project, and then I simply with the pencil tap the grid, and you see there's a magenta rectangle. So that's kind of like our target. Click done, and this edge got projected onto the grid and into the sketch where I already drew these two lines. So this should not move, so we lock it, and then I move this and connect it there. Beautiful. Now on the left side it's connected, the two lines are tangent, so I can rotate this one now as much as I want. Very nice. So I showed you that there are actually 4 fingers. And on the right side, there are kind of like 3 fingers vertical. So let's draw a circle. And then this circle we set to be 10 millimeters. So it's 20 millimeters diameter. And I position it to here. Let's make a copy. And another copy. There we are. So plus minus now. I know exactly how high should actually this handle be. So when I put my fingers under it, I'm kind of like not touching the work surface. If I would like to have also a representation of 4 fingers in a line, let me show you a little nifty trick. So I draw a line. I'll rotate it like this and then select these 2 lines and say be parallel. Pretty cool, no? Okay, now circle, move this to this endpoint, and these 2 I make equal. When I make this 5, you see how the other one changes. This one here I can also move to there. Very nice. Okay. So, and now when I move this to here, I only want the distance there to be perfect. So this line currently doesn't really cut it. So I will do something like this. So these circles all are equal. And here comes now the nice trick. All these lines have to be equal. When this is 20, then this has to be 20. And tangent, tangent, and one line, this line, and parallel. And you see how this rotates? Isn't that amazing? Okay, so now I can just move this around and I always see what volume, for example, later would be occupied by 4 fingers. Very good. Okay, let's go back to the handle. There are my 3 lines. Here, this I will set to parallel, perpendicular, and perpendicular. So I have nice 90 degrees. The distance here should be 15 plus minus, because the thickness of the handle I would like to be 30 millimeters. Very good. Okay, so select with the pencil the sketch fill. Then with the pencil we will select an axis for rotation and then select revolve, and then it kind of like rotates or revolves that profile around that line and creates a cylinder. Very good. Nice. So how do we now create actually a transition or a connection? We could extend this, but yeah, that doesn't really look so amazing. Let's go to extrude. We can extrude this out a little bit as a new body. And this is for the distance, and this is for to taper it. So we taper this a little bit and a little bit back. Yeah, maybe a little bit smaller. Maybe 12.5. Very good. 15. 10. Okay, it really helps when we rotate around a lot. We also see here it is not in the wall. Now it is. And Here it is not through the wall. Very good. So why did I do this? So next step. We can join these two elements together. Then this I can move a little bit back, but it does not move the part down there. Here, this edge, I will fill it quite big, so strengthen it. This actually now helps me that I can bring this back even more, or I will just select this and start rounding it. There, beautiful. Let's bring this a little bit further to the front. I tried here to have a nice distance. Very good. Yeah, that looks really nice. Can we actually make this a tick smaller? And even that we can still do. Why would I like to do this? I would like the handle actually be a tick bigger, but I don't want the handle to be, or make the handle bigger. So this I will make just a millimeter smaller. And you see all the rest actually shrinks with it. Amazing. Now, let's see, 1 millimeter of rounding. That looks good. Then we can do the same here. That's good. The handle we will hide. Let's do 1 millimeter here. So you start, we're actually adding a little bit of the transition details. Very nice. Now when this should actually be a wooden handle, it needs to be connected somewhat. And I'm going to show you a nice process how I would continue modeling everything. So let's hide this for the moment. And this we will call pen. And this is handle. Very good. So we need through the handle some sort of a pipe. And then at the end, we need kind of like some sort of wire that can bend and could come out. So I do not want anything of this here to move. So this point here at the end, I will lock. Everything else is constrained. So you see, I cannot move this. I can add a small line down here. Make this parallel. Not tangent. Perpendicular. Perpendicular. Very good. Let's see, what's the distance here? 6, so 5, that's 1 centimeter. That's actually quite big. We make this 2.5, so 5 millimeters. And then we rotate, select this, and revolve. There's our little kind of like tubing. What's the length? Let's make this 80, a little bit bigger, still too short. Okay, so this is 120, and I know that this is actually 130, so this is 1 centimeter of a distance. This might be good. Okay. Very nice. To turn this into a tubing, very easy. You can select the front and the back if we want to. Go shell and 2 millimeter material thickness. However, is too small. 1 millimeter, that looks better. Very nice. There's our tube. That's how easy you can make tubing. This is a 3mm diameter, so we can later put a 3mm wire into it. That's a little bit too small. So this we will turn now into 3, and then this we will turn into 2. So this is now 4mm. That feels better. Okay. Also there you saw I didn't really mess with the original sketch. I simply started adjusting the geometry. So there's again our handle. Let's cast aluminum, and then this somewhat will be connected, welded into it, and we could call this one rod or tubing that's inside the handle. Very good. Okay, so now we have to model everything for the hook. Yeah, so how do we do this? We have pretty much everything what we need already. So here we have a line, and there we have this. So let's do the following. Again, this is all static, so it cannot move. Not static, it's incorrect. It's constrained, it cannot move anymore. So I can freely start sketching around. First, I will turn the handle on. So I will make here a circle and then see if, as a hook, how big do I want this hook to be? 10mm, so 2 centimeter. 2 centimeters. That looks pretty good. It's not too big, not as thick as the handle. So that's good. Can put this to somewhere else. Actually, I can delete it. I just have to memorize 20mm. So kind of like from this point, I would like a curve coming out. We can do this with an arc. And then this arc, we will tangent constraint to this line. And then from this arc, I would like another arc come out and nearly form a closed circle. But this midpoint here, I would like to be kind of like on an axis. So as you see, I just draw myself here another line, make these two lines tangent. Then this should be 10, and this point has to go to there. But before I do this, these two arcs we make tangent to. So when I bring this one down, there you see how the first arc doesn't collapse. Very good. What's the radius here? Let's maybe make this 4 or 3. Here we can get this closer. There we say 340 degrees. Okay. That should, in theory, do it. And now I need something to run across this. Okay. So I will hide everything here. Okay. Go to there. This is now a little trick. Make a revolve. There we are. Very nice. If I want, I could actually do it this way. So we said 120. Very good. Brings it back to the same position. And this should be 2. So it fits actually into the rod. And then I select this face, select this line, this arc, and then on the left side, select sweep. Okay, what did it say? Let's go to there again. It said invalid body. I have an idea why. So when something like this happens, troubleshoot. Okay, when I go with these two curves, that works. And look at there. There you see that actually the arc is inside actually my geometry. It's just touching it, but perpendicular from this point, it would be inside there. So that means this radius just needs to change a little bit. So 335. Okay, that probably will do it. So, oh, okay. Undo, because I did a sweep while joining. 335. Let's do this again. So U and long. U, and U. Sweep. There we are. Beautiful. Round this a little bit so it's not too sharp. They're all one. Very good. Very long. So this we bring back. You might ask yourself, what happened there? Well, there are actually two elements. The original pin we created, that one we can delete, and then this new extrusion. There, very nice. There we are. Okay, let's take a look. Let's bring this down a little bit. So this can then sit in the rod. And now, with the handle, how do we finish all this? Let's call this ring, and then I will turn on the handle, turn on cut section. You see it's solid. Then I will turn on the ring, double tap the handle, double tap the ring, and then select subtract and keep removed body. Click done. Very good. Go back to this view, and now let's turn off the ring. Look at that. You see, there's a hole. So let's do the same also with the rod. The rod is really inside there right now, so you don't really see it. We can also select our objects here, first the handle and then the rod, and subtract. Done. And yes, we have actually two handle objects in this case. See here this core, which simply delete. Very good. And there you can see how we have quite beautifully this geometry of a wider tunnel for the rod to go in, and then a smaller tunnel for the ring to go in. We want to be a little bit more detailed. This edge, think about it, just with a little bit of sandpaper, we just clean up. Very good. And also here, when we push everything in, that should be a little bit round, makes it easy during the assembly. And very nice. Now in this presentation right now, you can see the ring is positioned this way. If we would like to rotate it, we can double tap it to select the whole body. Then our widget we bring onto this line, and then we can go into a rotate view and simply rotate this 90 degrees. Very good. Let's turn off show hidden edges. We can also name our sketches. So this is pen, handle. Let's bring them both below. Very nice. If we want tiny detail, just breaking these edges just a little bit. Half a millimeter, okay. Let's take a look what will happen if we do this here. Looks good. What about this one? Yeah. Very nice. And there we are. That is how easily you can model a Japanese frying pan just out of a very basic set of geometry, like a rectangle for the pan and a rectangle for the handle, and just do all the additional modeling or detailing just via a smart combination of direct modeling. So we also have some chopsticks. So let's quickly do those. This is also another really fun example to show you how powerful basic sketching and more detailed direct modeling can work. So there, I will go this way, double tap and horizontal vertical. This one I will set, okay, I have to zoom in a little bit. This one I will set to 8 millimeters. These two I will make equal. So if I make this 12, you see how this proportionally grows. Very nice. Then the whole thing is 420 millimeters. So 210 one direction. And then 420 the other direction. Or 420 the other direction. Very good. Now this is really long and a beautiful rectangular block. The tip I would like to be smaller. How do we do this? Really easy. Well, let's select all these 4 edges and then we go to scale and simply scale this down by 50%. There. And you see? So I just tapered this via scale. I could also, I will actually do this from here. I could also have extruded this out as a new body and then applied a taper this way. But you see, this is actually tapering it based on kind of like a degree. And here I tapered this by scaling it. And I scaled it 50%, which means this edge is 4 millimeters. And now I can go ahead, select all these 4 edges, round them. Let's see, 1 millimeter. How does this look? 2 millimeters. That is making this round. 1.5, 2 millimeters is, 1 millimeter is good. And then to make this really nice, no sharp edges, 0.5. Yeah, this is good. Let's make a copy. And we can name this chopstick. And give also our objects proper names. This really helps to organize actually our file. Because if you later have 10, 20, 30 objects or sketches and they have non-very descriptive names, it's very difficult to understand who is who. And this is it.